particles can move to different energy levels? Nick, what do you want to say?
I would say yes, because I think if you add enough heat to the particles, would it get fast or excite enough?
Okay, we know
break
heat.
away from each other.
Good. Okay, we know heat causes particles to have more what?
Accelerate.
Not accelerate, they have more.
Energy.
Then they speed up, right? We have been talking about that there are forces holding this atom together. There are forces holding the electrons together. When we increase energy, right, by heat, then that energy causes an increase in motion, so it speeds up, this electron speeds up, and it can actually move to another energy level. Freezing would be heat, okay, because the absence of heat is cold, okay, good. So if we change pressure, then that also causes an increase in energy, right? And then that also causes electrons to move. So what's really cool about today, guys, one of my favorite days of today, is that we get to talk about metals. One of the cool things about metals, and one of the reasons why we haven't been able to talk about metals, is because we didn't realize that their electrons are weird. They move quickly. Their bonds are a little not as stable, so they move energy levels really quickly. And when they move energy levels, cool things happen. So I don't know, Jazz, can you see back there? Can you see there are two triangles?
Two triangles.
Oh yeah.
Oh yeah.
This is a light blue in the center,
Yes.
and there is a darker blue around the outside. Where do you think the hottest part of the flame is? William?
I would say on the outer part, because on the inside of the flame it's hollow.
Okay. So I have a wood splint here, and I'm going to run this through the top. Not fire.
It's gonna get caught on fire.
I'm going to run it through the middle. Why is this not catching on fire, guys?
Because it's too
Not
fast.
hot enough.
There's no time to heat it up.
The flame is on the very top.
Oh, okay. So let's see when it actually starts to burn. Oh. So it doesn't burn until it reaches which part of the flame?
The middle
The
part.
top of a flame is always the hottest part.
Not
The middle.
the top of which color?
The
Oh,
The
dark, light,
blue.
light,
The
light.
light blue. Okay, guys, here's the cool thing about Bunsen burners. Wait a second. Here's the thing about Bunsen burners. The hottest part of the flame is at the very tip of the smaller flame. So I can move something in and out of this top flame, and it doesn't start burning until it hits the top of that small flame. Okay? So what I've done yesterday is I've prepared some what we call solutions of metals. I've taken metals that are in a powder form, and I've made them into solutions. And we've got toothpicks stuck in them, and what we're going to do is we're going to, so now we have like metal solution on the toothpick, and we're going to run it through the flame, okay? And see what happens when we heat up the electrons. This is copper sulfate.
I knew it was green. I knew it was
You want to see a green color?
It looks like a charged creeper.
What?
Whoa.
That's really cool.
Wait, how is it?
It turns, it burns out.
Okay, so the color of copper is what?
Green.
Green. Okay.
Wait, isn't it like bronze color?
Yeah.
Oh, really?
No, but over
Yeah,
time
oh,
it
it
turns.
needs to oxidize.
Wait a second. You mean the physical color of copper is bronze?
Yeah, but after it gets
once you
exposed,
oxidize it,
Just
it
like
After
the
it gets
Statue of
exposed, it becomes
Liberty.
green.
Yeah.
But once you oxidize it, what?
it
turns
green.
different colors.
This one I haven't tried before, so we'll see if this works. This is copper metal.
It smells amazing.
No.
That one's more.
It-
They're
no, it's
still
green.
green. This is plain copper metal,
Well, look how it's just.
and it's just
Yeah.
sparking.
It's like a blue aurora.
Lithium,
I'm
right?
calling it. It's gonna be a dark red.
Is that like
See.
It's
metal
gonna burn
lithium
as a
or-
dark red.
Whoa. Smells.
Can you guys see this online?
Again.
Strontium. Strontium is all the way down at the bottom. You can find strontium all the way down in one of the
I'm
transition
saying
metals.
purple. I was wrong.
Red again.
What's red again?
I thought it was gonna be purple.
This one is potassium.
I thought it
It
was
might be
I
dark.
think it's gonna be a light color.
Oh wait, is there anything on that? No, nothing's on
Oh,
it.
it's like a
It's sort of like white. It's like white.
That's regular fire. It's very hot.
No, it's not regular fire. It's like a violet. It's like a lilac.
Whoa, that's cool.
This is aluminum.
Yeah.
I think it's gonna be like
Aluminium.
silver, maybe. Might be silver.
Wait, that's. Oh wait, it's sparked. It's sparked.
This one's got little sparkles in it.
Wait,
Okay, this is iron. This is iron.
It might be
I'm not
like.
sure about iron.
Iron has a blue. It's supposed to have a blue-violet color.
Oh yeah. Oh,
It's got a little bit of green in there too, probably because of the chloride that's in there. So what I've done here is I have placed solids. I'm not going to turn it over to you because that's all solids are going to fall. I placed solids of metals, okay? Now these are, obviously they're metals. They're not the actual metal, so they're not shiny. What they are is they are mixed with like a chloride. So they're mixed with a non-metal, okay? And that makes it like a powder, okay? So what you're looking at, even though this is calcium chloride, it's not calcium the metal, it's calcium the salt because it's mixed with chloride, okay? So that's what we're looking at here. So here's what we're doing. I'm going to put hand sanitizer on it because it's straight alcohol, okay? And what I've got 7 metal solids in the form of powders lined up on this aluminum sheet, and I'm just going to mix, I'm going to throw alcohol all over it, and then we're going to see what happens when we light it on fire, okay?
Let's see what happens when we light it on fire. Okay. Whoa.
Whoa! Yo!
That's so
It's like
Awesome.
green and red.
The fire's green.
cool. It's a fireplace, but in science.
Oh yeah, it's a fire. It looks like
Well, it's the Christmas fireplace.
So guys, the goal was to give you a rainbow. So I'm trying to get out, this is supposed to be red, and it's kind of getting a little bit of red. The goal was to get you a rainbow of colors, but these are what happens when electrons get excited, and they move energy levels.
Oh, look at the green one.
Okay, Jazz, can you turn the lights on, please? Jazz, can you turn the lights on, please? So the colors you see are when the colors you see is the result of the energy given off when the electron returns to its normal energy level. Okay? And remember, guys, energy is not created, nor is it destroyed. It's just transferred. Okay? So the energy from the heat, right, is transferred now to the form of light. Cool stuff, right?